Hello, now we are going to observe a problem that is zigzag level order traversal in a binary tree. So first of all we will understand the problem statement, then we will deep dive into the theory stuff, and then we will also code it up. So quickly let us understand here. So they are saying that they are giving a route. So here 3 is the route, and we need to go level order traversal like zigzag way. So level order traversal is nothing but BFS. I hope you know that. So its node value, okay, from left to right, then right to left. So this is the alternative way we need to do that. So suppose let's say 3, and after that we need to go 29, 15, 7 in this fashion. So first of all we will understand here with the help of the first test case. So this is the example 1. So in this example 1, so let's say they are giving 3. So this is the given one, 3. So 9, 20, null, and 15 comma 17. So this is the input given array, right? This is the input given array, and we need to return the answer as like in this fashion. First we need to go in this fashion, in this way, next come here, and in this way we need to go. So for the simplicity purpose I will be going to show with the help of arrow marks also as well. So first what we need to do is, so I hope you observed that. So the first node is 3, okay, the first value is 3, the next value is we need to go in this fashion, okay. So in that array we will be going to have 20 comma 9, okay. Next we need to go in this fashion. So here we do not have nothing, so we can ignore that and we can simply say 15 comma 7. So this is our final answer for this tree. So in this way only, if you see another example, like let's say if you take let's say 1. So if you want to dry run this, so first of all, as this is the BFS, as you know, we need to traverse here, here, here in this fashion. So as we know that we need to go here in this way. So as we need to go in this way, as first level we need to consider, next level we need to consider, after that next level we need to consider. This is the level order traversal. So level order traversal only we will simply call it as BFS, breadth first search. So first of all we need to understand, for the BFS we are going to use the data structure queue, and for the DFS we are going to use the data structure stack. So we have understood that we need to use queue. So as they're expecting the result in the vector form, as we can see over here. So this is not a simple vector, this is vector of vector. So we are also going to declare a vector of vector. So for the answer, for the storing of answer, we are going to have the vector of vector. Inside we are going to store integers, and let's say we can call it as result, okay. So this is the result vector ours. So let's say this is the q, we will name it as q. So let us understand how the flow works, how the stuff is working and all. So first of all, if you consider this one, so first of all we are going to push this one into our queue. So first one is coming into the queue, and into the result we will keep that as it is, we do not do nothing. So after this one, when we are popping from the queue, we are going to place their children. You can see one has 2 children, which is 2 and 3. So while we are popping from the queue, we are going to place 2 and 3 in the queue, and after popping we will see, so is there anything in this result or not. So if nothing is there, we are going to place that the first element after popping here, we are going to place that in the result. So we are going to have a simple thing that is known as let's say a boolean flag, let's say left to right. So left to right is a boolean flag which is initialized with the let's say true, which is nothing but it is indicating that we are moving from the left to right, okay. After popping this and placing here, these two are stored in a like a vector that we are getting this from size. We can place that 2 elements in here, but in the reversed order, like 3 and 2. But before popping the 2, we are going to check the 2's children, that is 4 and 5. So you can place 4 and 5 here. So after you are popping these 2 and placing that, but before that you need to place the children of 3 also as well. The children of 3 is 6, so you can place 6 over here. So after placing 6, you can see all these 3 elements are having the same priority. You can see over here, same priority. Here the boolean flag will be true, here the boolean flag will be false in the second level, and finally again the boolean flag will be true, means the left to right is true. So without here reverse, it is reversed order we need to place, because in the queue we have 2 and 3, but while coming out we need to reverse this, and we need to place in this vector, means the result vector. So after if you see 4, 5, 6, as the output is coming in this fashion, for the queue it is coming in this fashion. So we are going to place the 4, 5, 6 as it is, 4 here, 5 here, 6 here. Why? Because as this is the boolean flag is true in this fashion, in this way, so we are going to place that as it is true, the same order we are going to place. I will show you the code so that you can understand clearly first of all. So as I said, we need q. So we need q and we need a data structure to store the answer, because see, they are asking vector of vector. So first of all, I will declare that only. So you need to have a vector of vector. So inside that we are going to have the integers, and I will say as result. Okay, there is no issue. So after that I will have a simple check that if the coming root is equals to null. If the root is null, what you will do is you can simply return the, if that is true, you can simply return the result. Why you can return the result? Because if that is nothing, the root is nothing is there, so you can simply return the normal empty vector. So after that you need to declare a queue which can store a queue nodes, means the tree nodes. So it is of type tree node, and I will name it as queue. So first value that you need to push is a root value. So into our queue, first of all we need to push our this tree. After pushing that, you need to run a while loop. So you need to check while this queue is empty or not. Until this queue is empty, we are going to run this while loop. So I am going to say while not queue.empty, because our queue should not be empty. So that's the reason that we need to run here. So after this we need to check the size of the queue. So I will say in let's say we will call it as size is equals to queue.size, because we need to find out the size of the queue. So after finding the size of the queue, the next step that we are going to do is, so we are going to have a temporary vector which can store the integer values. So I will name it as a row which is of size, because so this is a temporary vector that whatever the result we are getting in this, we are going to store that in the result. Okay, so after that I will be going to run a for loop. So let's say it is going from I is equals to 0 to I less than size, and you can increase the size. There is a simple for loop. So inside this for loop, so I will be going to have a tree node. Let's say I will call it as node. So I will have the node as a friend value. So whatever the friend value that is in there in the queue, that I am going to store in this node. So after that I am going to pop that first value. So I am going to pop that first value. After popping that, so the next step that we are going to do is we are going to find out the index. So let's say I am going to find out the index. First of all, as I said, we are going to require a boolean flag. So I will quickly declare here a boolean flag. So boolean flag, let's say I will declare it as bool. So I'll name it as left to right. So in this left to right, I will let's say true. For simplicity, I am saying true. So here let's say we are going from left to right only. Like let's say the boolean flag is saying true, which is nothing but we are moving from in this fashion. So let's say left to right. So if this is true, we are going to use the ternary operator. If this is true, then we are going to simply use the current condition which is I. If that is false, then we are going to say sum minus I minus. So this is not a simple index which is pointing to the last word, because if the left to right is false, okay, if the left to right is false, which is nothing but the boolean flag has become false. So now we are going to move in this fashion. So we need to print in a zigzag way. Now we are going to print 20 and 9. So for that purpose, we need to get the last index to store in the queue. So this is the way how you get the last index. So after getting the index, so we are going to say, so we are going to store that in this row. Okay, so row of index means row of this index. We have got this index with the help of this. Inside this row means inside this row vector we are going to store node value. So after storing the node value, then we need to push into the queue. So if node dot left, then what we can do, we can simply queue dot push. So we can push the node dot left. Okay, this is as simple as that. So after having this, you can also have the node dot right also as well, and here also instead of node dot left we are going to have the node dot right. So after completing this node dot left and pushing into the queue, so now we are going to make the boolean flag false. So I am going to say left to right is equals to not of left to right, which will invert the boolean flag. After that I am going to store whatever I am getting in this row. With the help of this for loop, you figured out what are the values in that row. So now you can simply store that in this result. So I will simply come here. I will say result dot pushback, as this is the vector. I will simply say result dot pushback, and inside that I will push the row. Okay, and I will simply come here and I will return the result. So this is the way how you code up. So let's quickly run this. So you will see it is working absolutely fine. So I hope you understood this. Now let's submit this. So you can see it's preparing the runtime, and it has been successfully passed all the test cases, 33 test cases. So this is the way that how you write the code of the binary tree. So zigzag level order traversal. So now finally we need to understand the time and space complexity of this algorithm. So the time complexity will be order of n. Okay, the space complexity will be order of n, which is that we are using the for the result. So generally we will not consider this result because we are returning this only, but we will consider the queue data structure, which is of size n. So that's why I am saying the space complexity is order of n and the time complexity is order of n, which is the